Thank you, Savinia. I think you actually almost told the whole story of Starship already, but I am doing my best to repeat at least the best parts of it. So yes, Starship is doing last mile delivery, and so I'm not going to talk about the whole of supply chain today. I am actually talking about just the delivery, like the last part of logistics, getting stuff into people's homes. And now let's begin by looking at what do actually consumers want about getting things to their home, apart from the things themselves. Then what are the qualities or characteristics of the delivery that they want? And there are a couple of things in here that are obvious. Of course, they want it to be free, because the delivery or shipping has actually become quite significant portion of the cost of things that people order, from the internet, for instance. The delivery is a significant part. Sometimes people order toothbrushes from China. It actually does happen, and then the toothbrush costs, very, very little, and the delivery costs actually more than the toothbrush. So people don't like it. People want to have it free. Secondly, they want to be able to return items, and they want the delivery to be pretty much, instantaneous. They when they order something on the internet, they would ideally want to receive it, immediately. That they click OK, buy, and then somebody knocks on the door, or the item somehow appears. So at some point, 10 years ago, people were happy that that they get it at all, that they click buy, and then next week, it arrives. Nowadays, especially the millennials or people who are less than 20 years old, they're, everybody is accustomed to getting things, immediately, instant gratification. They want to plan ahead for like 2 weeks that, okay, I'm going to receive this thing, somewhere in the future. So that's also, of course, why the delivery cycle has become shorter and shorter and shorter, and it's now something like next day in some places, like in San Francisco, Amazon delivers same day and so forth, but people want it to be like the same hour, or they want it to be same day always. And they also want to know where their shipment is in real time. And they also want to have kind of a personal service that the experience that they get with like Uber, for instance, that they click, okay, I want to get it, and then they see on the map how this thing is moving to me. Now, those are all great things. Those are the things that the consumers want. But the problem is they want this really, really nice thing, but to actually offer something like that to them, that's the most expensive kind of delivery service that you might imagine. The only way delivery has some sort of a reasonable price today the whole reason is that delivery companies are able to deliver something not by the same hour, but by the next day. They can actually optimize their driving routes. They can gather all the parcels that they need to ship during the next day. They gather them in the morning, they load them into a truck, and they optimize the route of the driver. So that's actually the opposite of that. It's the opposite of that personal service and being able to track where your shipment is and arrive when you want it to arrive. So consumers want this best possible service, but they also want it free. They don't want to really pay for it. The kind of the standards, where our world has evolved, this instant gratification thing, it's pretty hard to fulfill, especially at the zero cost. And if we look at the costs, then the thing is, the main drivers of the costs in delivery, they are not really going to decrease. People are expecting that the price of everything is going down, but the price of delivery is actually not going down. And it's not going down, mostly because during the delivery there is a phase where the courier is handling just your shipment, just your parcel. Like, for instance, the phase where there's the delivery van and it stops in front of your house, and the driver stops the car or finds parking space, stops the car, gets out of the car, walks to the trunk, gets your shipment, walks to your front door, knocks on the door, waits until you respond, all of those things, and then gets back to the car and so forth. And those things, take, at least, something like 5 minutes, if not 15 minutes. It depends, on the, geography and so forth. The thing is, during these 5 minutes, or during this 10 minutes, or 15 minutes, or whatever it is, during that time, the driver is your personal servant. The thing is, the driver is handling just your parcel, is doing something only for you. And who is paying for that? You are paying for that. So the driver is your personal servant for, something like 10 minutes. Now, a lot of people, or if you look at in the history and everything, there are a lot of people in the world who have, had servants, like kings and so forth. A lot of people can afford servants, but most people can't afford servants. In the whole of the history, most of the people in the world, they have not been able to afford having a servant. So not many people today afford, paying somebody to, come to their house and wash their dishes. Most people can't afford that really, or even if maybe they could afford that, they wouldn't prefer to do that. They wouldn't want to do that. But everybody has a dishwasher. So they could afford a machine, a low-cost machine doing that job, but they couldn't afford a person doing that job. So with the growth of e-commerce and more and more and more things being shipped and ordered, from the internet and delivered to their homes, I'm arguing that this model doesn't scale, or this personal servant model doesn't scale. People are right now, the vast majority of things that people actually buy, they are not buying over the internet. They're physically going somewhere, buying something, and like driving their car, back to their home. Even if it's a toothbrush, they go out with like a 2-ton car, they drive somewhere, they buy this thing, this toothbrush, and they again drive this 2-ton car back to their home. So this is not efficient, but they are doing it because they don't want to pay to this personal servant, to do it for them. Now, machines, so like dishwashers doing delivery, so delivery dishwashers. So the companies, building robotic solutions, and in these pictures, the Starship robot, there's a self-driving car, there's an aerial, like drone doing delivery, and there's a self-driving truck. And a lot of those are, of course, not renderings; they're actual pictures. So people are actually building those things. They actually do work. They are at various stages of commercialization. So, like Starship robot, we are doing deliveries right now. We just started, but we are actually doing real deliveries in London. And the self-driving cars, those are a bit farther away in the sense that they are driving around, but they are not like in commercial operation. They're doing test drives, but they will come at some point. Of course, estimates vary, when that is actually going to be. Some of the optimists are saying it's going to be in a couple of years. In a couple of years, there's going to be a self-driving car on the market that you can actually, push a button and it will drive you, through the city. Other people are saying this is more like, 20 years away. And I'm not going to put, my prediction in there, but I'm pretty sure it's not going to be 2 years. It's going to be longer. So this is like an other end of the spectrum. So Starship is actually doing deliveries right now. Self-driving cars, could be a lot, especially in urban self-driving. That's a bit longer out. And then the flying machines. Of course, that's a regulatory and safety issues and things like that they still have to solve. But I'm absolutely sure they will also come. Self-driving trucks, Actually, this is a company called Otto in Silicon Valley. They're actually, the founders are my friends, so I've actually also had a ride in the same truck in California. So yes, it does drive. The steering wheel does turn by itself. We didn't crash. It does work. It's still a prototype, but but it will be a commercial product. So all of those things will actually be commercial products. And today, very few people have actually received any deliveries, by a robot. Like the Starship robot, some people in London have actually done it, have actually received some actual deliveries, like unsuspecting people who didn't know, who were not like friends and family and were not prepared for the robot, but they got the robot, and it worked. But still, to a lot of people, to the vast majority of people, this is still like, science fiction. This is like, they've heard of, people like me on the stage, talking about how the future will come and how everything will be robotic. But in reality, they'll go back to their regular lives and they forget about robots. But this change will actually happen pretty soon. If you live in the right neighborhood in London, this change will actually happen like maybe today or tomorrow for you. Now, some perspective I mentioned about this dishwasher and the personal servant and this type of thing. The funny thing is that delivery is actually the last major industry in the world where there is this kind of a personal servant thing, where there's actually a person who is by kind of a manual work is the centerpiece of doing some sort of work. Like pretty much all work, or a lot of kind of a manual work that used to be manual 100 years ago, has been automated, but not last mile delivery. So in this picture, you see a lumberjack, cutting wood in the forest, and if this picture was 100 years ago, 200 years ago, this person would actually have been a regular lumberjack, earning money in the forest. And right now, when you see that picture, what you think, who this person is, professionally, and what is he doing? It's actually evident that this person in this picture is actually earning money. He is actually earning money in the forest, but not as a lumberjack, but as a model. He's a model. So today everybody knows this guy is a model. This is not a lumberjack. 200 years ago, this guy was actually a lumberjack. Now, Starship is building land-based robotic delivery platform. And we are not up in the air. We are not building like 2-ton or 10-ton vehicles. We are building small, lightweight robots like this. I'm going to talk about a little bit of the history, how the sort of the thought evolved for us, and how we developed our company. So it began with different types of robots. So there is a NASA program called NASA Centennial Challenges, which is like an X Prize type of program. They set up prize money, and teams around the world they compete to solve some technical challenges. And in this case, it was building robots that could work on other planets autonomously, driving around and collecting rock samples. So the kind of the competition actually didn't happen on like Mars or Moon or something like that. It would have been really cool, but instead it actually happened in a city park, like grassy city park in Worcester, Massachusetts, United States. But I assembled a team to compete in that challenge. I hired 10 people, or well, some of them I hired, some of them were just working for this for fun, and I worked on that challenge for 2 years, or for it's a yearly competition, and we competed for 2 years, and that meant that I now had a robotics team. I didn't have that before, and we really liked each other. There were mechanical engineers, electronics engineers, software engineers, and there was a lot of talk, inside that group, that 10 people group, that let's do a startup. And I was always saying, no, I don't think, I had been the founding engineer of Skype before, and I've gone through startups, many startups, and I thought, no, let's not do a startup. Let's not do a robotic startup. It's a totally different thing than just engineering some cool robot to work on this NASA challenge. But then the idea of Starship came along. This NASA competition gave me a clear understanding that what does it take to build a robot that is approximately this sort of size, because the NASA robots were the same size essentially. How much does it cost? What kind of people do we need? What would those robots be able to do kind of technically, physically? How fast to move, how lightweight would they be, and things like that. So I knew some of the practicalities of how to build robots of this size. And that actually helped shape the idea. If that wouldn't have happened, maybe I would not have thought that that a delivery robot would be of this size and would move at this speed. So this is one of our team meetings, something like a year or a little bit more than a year ago. Yeah, maybe when the company was about 6 months old, and it's actually telling, this is in Tallinn, Estonia. It's actually telling, of the people's kind of temperament in our region here. Is that those guys they're engineers working on some of the coolest stuff. They're probably, it's the coolest startup in Estonia, and they're working on this self-driving robot that does deliveries. But yet you see only one person here who is like smiling or looking, excited, But this actually doesn't count, because this one person, he's an Australian. So we built some of the prototypes. Some of those things, were like, the ones in the back, it's like, wooden, stuff, just, quickly hacked together. So let's have something, driving on the sidewalk, and let's try out, how does this work? And then we built, different prototypes. We had industrial designers doing the industrial design of it and make the robot, look nice. And it took about a year, I think, to get like from this first prototype, down there or up there to the kind of the last thing, which was like a single item produced thing on the bottom here. And from there on, we started to produce robots in quantities of more than one. So this is a Starship robot. So let's have a kind of a closer look. So it drives like that. Right now, it's actually controlled by manual control from there, but it's generally an autonomously driving robot, and it weighs about 20 kilos, and that means it's lightweight enough that when it moves on the sidewalk with pedestrian speed, it's actually incapable of hurting anyone if there would be like a collision or something like that. Of course, there isn't a collision, because the robot has lots of sensors. There's 9 cameras, there are ultrasonic obstacle detectors, there are time-of-flight cameras, so it doesn't collide into people, but it's certainly one of the things that people immediately would think of, that would I get hurt? If there's a self-driving car, the first thing people think that, oh, what if this causes an accident? If this would ever cause an accident, there wouldn't be any damage. Now, most of the space inside the robot here is cargo space. When you as a consumer get your delivery, then it works that, of course, this thing doesn't knock on your door. This doesn't ring a doorbell. So it stays on the sidewalk, and you get a notification on your smartphone. So you take out your smartphone, you see that the robot has arrived, and then you click open here, and that opens up the locking mechanism here, and this turns green. Now you can open it up. You can't see it from the perspective here, but most of the space here is empty. Actually, during the coffee break, like after 10 o'clock, you actually have a chance of seeing the robot more up close and seeing what's inside or what isn't inside, because it's empty. And it's a 6-wheel drive robot. The rear wheels can be actuated. They move up and down like this. And that means the robot can climb curbs. It cannot climb stairs, but it can climb curbs. We thought actually initially that it's a critical feature to have the robot climb curbs. But we realized actually, pretty much almost all of the cities actually are wheelchair friendly. People whine about that. Not all of the places are accessible. Without climbing curbs. But actually, the vast majority of places are actually accessible. So that actually actually has not been so important as we earlier thought. And due to its low speed, like pedestrian speed, this robot, of course, is optimized for a couple of kilometers radius. So this is not going to deliver something over the distance of 20 kilometers or something like that. But this is for shorter distances, which is like walking distance. So if you can walk to a supermarket to buy something, then a robot could also do this. Luckily, supermarkets actually are within walking distance, or like almost walking distance, something like 2-3 kilometers from pretty much everybody, or from a lot of people. So you can see how this robot drives. So let's have it drive a little bit more on the stage in here. So it's a really nice thing, and people who see it on the sidewalk, they actually they perceive it as a kind of a friendly, cute thing. They are saying even that it doesn't look like a robot. And it's a funny thing that I mentioned earlier, like personal servants and dishwashers. So a dishwasher is also a robot. It's a fairly complicated robot. A copy machine is also a robot. It's a very complicated robot. Actually, a copy machine servicing company looked at the design of our robot, looked inside our robot and said that, oh, after copying machines, this is easy. And yet, people don't call copiers robots. People don't call dishwashers robots. Some people are actually saying that if it doesn't work, if something doesn't work, then they call it a robot. But if it does work, if it is at the level of commercialization and productization that you push a button and it does what you expect it to do, then they call it a dishwasher. Then they call it a copier and so forth. So we are also entering that stage where people are not calling it a robot. People are calling it something else by the function. They accept it on the sidewalks. And that has a lot to do with the design we have. Like when you say robot, then people expect to see some wires, tubes, something making weird noises like and so forth. Because there are some noises like that, because it is there are electric motors and gearheads and things like that in here that make a little bit of noise, but still the overall image of this thing is not like industrial. It's not technical. It's more like friendly. It's something that's made for the people. Like it's made by engineers but not for engineers. And due to its low weight and low speed, we call it inherently safe. That it can't kind of possibly hurt anyone when driving. So how does one do deliveries with a robot like that? So, like I said, this is short distance only. This is like walking distance. So Starship is offering delivery service in service areas, which are something like 10 square kilometers, or it varies by the topology and other factors. But let's say the average is something like 10 square kilometers, and we equip this area with robots. We build the minimal infrastructure needed for to charge the robots, to have them for the robots to have their place to spend overnight and so forth. And we are delivering three kinds of things: like packages, groceries, and prepared food. And this is on-demand delivery, so delivery which happens at pre-agreed times. So this robot is not it's not doing this thing that it comes to your house and then knocks on your door and then you're not home and it goes back. Well, of course, yeah, it will go back eventually if you're not at home. But in general, this is pre-agreed times when the robot drives out. And I mentioned that we are equipping the area with minimal infrastructure. So this is the infrastructure. This is actually not a minimal infrastructure, but even a bit more advanced version. So this is a Starship Hub, which is a sea container-sized thing that we are developing, which houses a number of robots. Robots go in there, they charge there, and we are building automated warehousing system to automatically load the robots with cargo inside the hub. How it works from consumer's perspective is that all of the interface is essentially digital. So the consumer orders something on the internet, and they get a notification on their phone that the delivery is ready for them. So then they can pick a delivery window, and we are not doing like 2-hour delivery windows or anything like that. We are doing 5-minute delivery windows. So it takes something like under 30 minutes for the robot to drive to your house. So there's no need to plan that ahead, for until like next day or something like that. You can do it in a way that when you are home, you say you click, okay, let's do the delivery right now. It's quick enough that you don't need to plan ahead very much. Or you can do it in a way that when you are leaving work in the evening, then you pre-agree the delivery in 30 minutes. You know that you will be at home, for in 30 minutes. So that's when you're getting your delivery, and then you see on your smartphone on the map, you will see how the robot is approaching you. It's like an Uber type of kind of thing, and then when the robot gets to your house, then it stays on the sidewalk, and then you come out and make another click on the smartphone, and then you can take out your parcel. So due to this reason, also this is not actually suited for the dense middle cities, like it's not for Manhattan, for instance. But there's high buildings or big apartment blocks, because people actually would have to come out to the sidewalk. So it's more suited for the suburb, for the residential suburb, where there's also less traffic, and it's easier for the robots to drive on the sidewalk, because there are not so many pedestrians. And so the economics. That's very important. I mentioned that that people cannot afford this personal servant, but they are able to afford the robot. So our target price for the last mile delivery is something like 1 to 3 euros. So we will probably be at 3 euros next year, and 1 euro in a couple of years. And the thing with the cost of the robotic delivery is that I said earlier that for the traditional delivery, the costs are not going to decrease. They're actually going to increase, and they're going to increase primarily because the minimum wage is increasing all over the world. But at the same time, the cost of technology, obviously, is decreasing all the time. So the costs that Starship has, or any robotic delivery system has, the costs are technological. It's the cost of components, it's the cost of maintenance, it's the cost of those things. And those things actually do get better over time. They get better over time even if we are not doing anything about it. The components we are buying in are getting cheaper. They're getting more reliable, meaning they don't need servicing. They don't break down so often. So our costs, whatever number I would say here right now, I could say half a euro. I could say 1 euro. I could say 3 euro. I could also say 20 cents. It's just a matter of time. In 10 years it will be 20 cents, or it will be zero. It could be hidden in the cost of the thing that you're buying, even if it's a toothbrush. So our current status is that we have driven 12,000 kilometers with those robots. We have 40 of those, and we have encountered 1 million people during that process. During this testing period, this 12,000 kilometers, we have actually driven in such a way that we have had, just for safety, we have had a person walking with the robot all the time. So about half of our company are actually people walking with the robots. But of course, they are autonomous driving robots, and this walking with the robots is necessary for a test program. But of course, this is going to end fairly soon. There's some pictures. People love our robots. People really, really love our robots. We have had actually, sorry, we have actually had people treating it as a pet or offering banana to the robot. Yeah, some pictures. So we have driven our robots in more than 40 cities in the world, and have universally gotten the reaction that that people love it. Sorry. And we have started our pilot programs. So we have partnered with 4 companies. Some of them, major players in the market, like Just Eat, the food delivery service in the UK, and Hermes, which is the second largest delivery company in Germany after DHL, and also Swiss Post, you can see on this slide. We're running around in Estonia a lot, where our R&D office is, and in the US, this is in Washington D.C., where we actually used our robot to deliver a piece of legislation, because Washington D.C. is kind of a state. It's like a very small state, like legally, and they passed a law to regulate robots like this, to declare where robots like that could drive, where they could not drive, and so forth. And that's really important, because the thing is, the traffic laws in the world, they are not written with robots like that in mind. So that actually has produced a situation where in a bunch of places in the world, robots that are technically illegal on the sidewalk. And in a bunch of other places, like Austria, for instance, they're completely allowed on the sidewalk, because it depends on kind of random, 100 years ago or 50 years ago, when people were writing traffic laws, then which way did they write? Did they write that small wheel things could be on the sidewalk or not? So the Austrian traffic law actually has a special section for like what they call, I think, small vehicles. I think it was Kleinfahrzeug or Leichtfahrzeug or something like that. The definition of which perfectly fits our robot, but of course the law was created a lot earlier. So I don't know why they did it actually, but sidewalk robots are completely legal in Austria, for instance. They're also completely legal in Norway and in a bunch of other countries and US states, and then they're completely illegal in some of the other places. So of course the legislators, they understand. They understand, our vision. They understand that delivery will be robotic. They understand that it has a lot of benefits for them. Like, for instance, if people are no longer spending so much time, driving their 2-ton vehicles to grocery stores, but instead have, light robots like this doing the delivery for them, then that means it reduces congestion, it reduces car use, it reduces needs for parking spaces. It enables elderly people live longer lives independently at home, because some of the elderly people and disabled people, they need a personal servant to do their shopping. They could have a robot. So it ticks all of the things in a political agenda. So the cities, municipalities, politicians love us. So they will actually, in the places where robots like that are illegal on the sidewalk, they are actually changing the laws to allow robots like that. And Washington D.C. was the first place where they actually passed a law to make robots like that legal, where they were illegal before. And we have commercial trials underway now, so that's an important point. So you could. I showed you photos about self-driving cars and so forth, and it's always a question for people that this is the future. This is far away somewhere, but we actually are doing commercial trials right now, where people, unsuspecting people, are already getting deliveries in London with robots like this. This is a continuous service. We're doing it with a couple of robots so far, but of course we are going to increase, and this will actually become a commonplace thing. So I finished my presentation with that slide. So Starship is the delivery platform of 2016. So this is, when we talk about kind of the future, this is not 2025, this is not 2030, this is not 2017 even. let's say, 6 months ago, I would have said, that Starship is the delivery platform of 2017, because, for a startup, it's always, it's nice to say that we're coming next year, but this is like around the corner. We are no longer actually around the corner. We are already there. We are doing commercial deliveries in London right now. So thank you.
Take some water if you want.
Yeah.
Ahti, thank you. And this to me is a bit like, the modern version of R2-D2. It's
Yes.
But a lot of questions come to mind. I'm just thinking first, bearing in mind your experience of Skype, and you've then transitioned from software to now hardware. What are the sort of the similarities between Skype and Starship Technologies?
I think the main similarity or the main parallel there is that Skype obviously disrupted like telecom industry in a way, or it enabled people do long distance calls essentially for free, and that had a big impact in the world. And the thing is that me and Janus Ries, who founded Starship, the thing is that when we started brainstorming that what are we going to do next, so what are we going to do next? A lot of people are building robots that, in my mind, are solving trivial problems, or solving like really small problems, doing some sort of a curiosity thing. But after Skype, we didn't want to do anything like that. We wanted to do startups that would change the lives of like everybody, or have a really big impact in the world. So that's sort of a setting of the bar, how disruptive, how big, how relevant we want to be. That was a parallel with Skype, and maybe if we hadn't done Skype before, we had set the bar low. But we from the outset thought that what can we do with robotics that could change the lives or change the world for everybody, for a lot of people? What's the service? What's the thing that everybody needs? Delivery is what pretty much everybody needs, and increasingly.
And I mean, a lot of thoughts comes to mind. It's practical. It's definitely, walking the talk of robotics that are there now. But I'm thinking practically, in big cities, if they're going to be invaded by these machineries, I'm thinking space. I'm thinking, well, security you took up, pedestrian crossings, theft. I mean, are there a lot of sort of cons as well as pros?
The thing is, all of those things either can be solved or we have solved already. Okay. So people certainly have questions. How does this work? Is this really, But first, like I said earlier, this is not for the middle of Manhattan. So this is not intended for, like driving, through this room where there's so many people, for instance. If you all stand up and we want to drive the robot through the room, we wouldn't be able to do that really. And that's not the environment where this robot is meant for. It's meant for the suburb, for the residential suburb, with individual housing, where there usually are sidewalks, which are most of the time empty. There is one person maybe after each 100 meters or 50 meters or 20 meters. And there, robots like that are perfect. They do not disturb anyone, and they of course they sense pedestrians. They keep their way, they keep their kind of a lane. If there's a sidewalk, then they would drive on the right side, kind of, and they would notice that there's a pedestrian approaching, and on the sidewalk, when two pedestrians are approaching, and research has shown that they kind of negotiate with each other at about 15-meter distance, that which way are they going to pass. Our robot does the same. So this actually does work. And in terms of acceptance by pedestrians, when this was just an idea, and we were theorizing, what would be the problems and so forth, we were actually thinking that what's the percentage of people who would call the police when they see a robot like that? And we actually thought, this could be a big problem, but our first field tests immediately showed that this is actually that's a complete non-issue. So we have met 1 million people so far, and nobody has called the police. And in fact, you will not believe it until you see it. But it's actually true that about 80% of people ignore the robot. They actually do ignore. A robot is here, I'm just walking here, I'm just not even looking at the robot. I'm, talking with my phone. I'm talking with, a friend,
Exactly.
I'm, looking at, where I should go. I'm on the Facebook, or, I'm looking at Google Maps, where should I go? And most of the people actually do not pay attention to the robot. They give like one look, maybe they give one look. 80% of the people, they don't give even one look. Then, it's something like, 15% of people give, one look and not more. Even, things like there's somebody, with a baby carrier, a baby stroller, walking, you would think that okay, they're really protective of their, baby, and, they see a robot, they're afraid. They kind of, keep away from the robot. That's not true. That's not true at all. There's a robot, driving, and somebody goes with a baby stroller. They give one look and then just pass right, in front of the robot. The robot stops, of course, but it's amazing how kind of natural it is on the sidewalk, and you will not believe it before you see it, but it is reality.
I don't know if that's a good thing or a bad thing. It sort of shows our attention span, if not else. We don't even notice a robot. I know time is running out, but I would like to give the audience an opportunity. Does anyone have a question they'd like to ask? Okay, there we have one. I don't know if we have a mic yet. A mic, quickly. Perfect. Maybe you can pass it along.
The traditional delivery driver, one of his kind of accidental roles is also as a security guard, both to protect the contents and to protect his van from being stolen. This very attractive 20-kilo piece of tech, what sort of level can you do to stop it being stolen?
Yeah, so
Or
everybody
invaded?
asks that. It is not so easy as people might think. Because I said, it's 20 kilos, you can lift it up, but it's kind of hard to actually run away with the robot, especially when there is a really annoying alarm sound going on. The robot is rolling its wheels at the same time as you are carrying it. There is a speaker and microphone in the robot, so that there's an operator who is actually yelling at you and saying that they're calling the police. then the robot has 9 cameras, so you need to smile, you're on camera. And the thing is, why are you doing this? The most expensive component in here is an industrial gearbox, which costs 70 euros. And nobody wants that second hand. If you want to steal it for the contents, there's a nice thing about it, is that you can't see what's inside. If you look at statistics of who is breaking into parked cars and why, then nobody's breaking into the trunks of parked cars. There could be something valuable in there, but they're not doing it because they're not sure. They don't know what they're getting, and if they're getting anything. If anyone is breaking into a parked car, they're doing it through the window, because they see what's inside. About half of the time, a robot like this is empty. Like with a UPS truck, that's actually not true. That's actually most of the time, it's almost never empty. But this is like a personal delivery device in the sense that it does just your delivery and then goes back. So half of the time, it's empty. People don't know what they're getting. And obviously, we are not doing deliveries actually for like jewelry or something like that. So it's mostly, low value items. It's the everyday things that people, want to get, really quickly. So it's generally low value as well. So we obviously, haven't had, any problems with that. I actually think, we will have problems with that, but very small problems. The delivery industry actually does have theft already right now. Like in London, delivery companies are telling us that about 1% of food deliveries actually go missing, and they go missing because somebody jumps in front of the courier and says, give me that pizza or I will kill you. And of course, the courier is instructed to give the pizza because the company doesn't want to pay for any like injuries or anything like that. So 1% of like pizza deliveries are lost because of that. So we will also lose some percentage, but we think it's not going to be very big.
Okay, so like Ahti says, grab him in the break if you want to also look inside. And we're going to have, Ahti, thank you so much. And really, we're looking forward to seeing it in Scandinavia too soon.
Yes, absolutely.
Okay, thank you very much.